begin our study of simplifying nth roots, we're going to review simplifying square roots, which you've done in the past, and it'll help to explain what we will do with cube roots and fourth roots and fifth roots. Here are some square roots. Before we start these examples, let's talk about the square root of x to the sixth. X to the sixth means we have 6 factors of x. And if we're asked to find a square root, we're looking for 2 matching factors. There's one, a second one, and a third one. So the square root of x to the sixth is x cubed. There were 3 pairs of factors of x. If we had square root of x to the fifth, that means we have 5 factors of x. And a square root means we're looking for how many pairs of factors, matching factors. There are 2 pair of matching factors and 1 left over. So that's what we're thinking for the next examples, but we don't want to have to list out all those factors. Those exponents are much too large. So when we simplify to get our answer, we have to keep the ideas I just demonstrated in our minds. And the thought process allows us to think about 1 factor at a time. The square root of 144 is 12. It's a perfect square. The square root of a to the 16th, that means there are 16 factors of a. Square root wants us to find how many pairs. 16 divided by 2 is 8. Also in our thought process, we'll look at b to the 12th. That means there are 12 factors of b. This is a square root. 12 divided by 2 is 6. And that should have been a b. Last step in the thought process, I have 10 factors of c. How many pairs? Because it's a square root. 5. That means we started off with a perfect square. All of those elements were perfect squares. There is not a radical left as a part of our answer. And down here, this is just our thought process. We don't want to have to take the time to write that out, but that's what we want to think as we're working. In the next one, we do not have perfect squares, so we will have a radical left in our answer. We will have a square root left in our answer. And again, the thought process is, what's the square root of 48? 48 is 16 times 3, so square root of 16, square root of 3. Square root of x to the 11th. 11 divided by 2 is 5, remainder 1. 15 factors of y. How many pairs? 15 divided by 2 is 7, remainder 1. And finally in the thought process, 7 factors of z. 7 divided by 2 is 3, remainder 1. This is our thought process, and as we were thinking through these steps, we could have started listing 4, remainder 3. X to the 5th, remainder x. Y to the 7th with a leftover y. Z cubed with a leftover z. I wrote that down wrong in my thought process. And that's our completed answer. We'll use the same sort of technique for cube roots in the next video, except instead of pairs of 2, we're looking for groups of 3 to accommodate a cube root. After reviewing square roots, let's shift gears and talk about cube roots. Before we start these examples, think about the cube root of x to the 6th. The root index is the number inside the elbow of the radical sign, and it means we're looking for groups of 3 matching factors. So if I have 6 factors of x, cube root means we're looking for 3 matching factors, and there were 2 sets of 3. If we took cube root of x to the 5th, we have 5 factors of x, only 1 complete matching set of 3 factors, with 2 factors left over. So we're actually dividing exponents by 3. 6 divided by 3 was 2. 5 divided by 3 is 1, remainder 2. This x has an automatic exponent of 1, so 1 remainder 2. That's the thought process we need to keep in mind for examples 3 and 4 from our notes. We don't want to have to list out all of the factors because these exponents are too high. So first we want to realize that 27 is a perfect cube. And if my exponents are divisible by 3, multiples of 3, then they are also perfect cubes. The cube root of 27 is 3. The cube root of a to the 9th, we have 9 factors of a. 9 divided by 3 is 3 sets of 3. B to the 15th, we have 15 factors of b. How many sets of 3? 15 divided by 3 is 5. And finally, 3 factors of 3. How many sets? 3 divided by 3 is 1. So everything inside of that radical was a perfect cube, and my answer no longer has a radical in it. That'll be different for number 4. Number 4 will still have a radical because we don't have all perfect cubes. So we want to think, again, thought process. We don't want to have to write everything down. That's what we need to practice for. But to get started, we want to think of cube root of 48. It's hard to shift away from square roots. What are perfect cubes? 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. Well, that's too big because we're just trying to find the cube root of 48. So what I want to recognize is that 48 is 8 times 6. Let me say that a better way. What I want to realize is that 8, which is a perfect cube, happens to be a factor of 48. And that way, the cube root of 48 is 2 cube root of 6. So that would be 2 cube root of 6 in my answer, but there will be other things. 10 factors of x. How many groups of 3? That means we take 10 divided by 3, which is 3, remainder 1. Now we'll think about y to the 8th. 8 divided by 3 is 2, remainder 2. Finally, the z factor. 13 divided by 3 is 4, remainder 1. So we have simplified square roots and we've simplified cube roots. Now we'll simplify some more nth roots, kind of generic. Nth roots. Example 5 is a 4th root, so we are looking for matching factors in groups of 4. In order to simplify 32, 4th root of 32, I have to know my perfect powers of 4. Pretty quickly, I should know them. 1 to the 4th is 1. 2 to the 4th is 16. Aha! 16 happens to be a factor of 32. So the 4th root of 16 is 2, with a leftover factor of 2. You just also still have to have your root index in the radical of the answer. Now let's look at the 4th root of x to the 9th. 9 factors of x divided by 4 is 2 with 1 left over. 15 factors of y divided by 4 is 3, that would give you 12, and 3 left over. 3 factors of z divided by 4 would give you a fraction. So those will stay inside of the radical. And these are multiplied even though there's a big space left over. 5th root. Let's start with the 5th root of 32. I would hope that you immediately recognize that as a perfect 5th power. 2 to the 5th is 32. Then, 9 factors of x divided by 5 is 1 with 4 left over. 15 factors of y divided by 5 is 3 with none left over. And 3 factors of z divided by 5 would create a fraction. And we're going to do that part tomorrow. So we'll leave those 3 factors of z inside of the radical for today.